So now let's look at an example involving sequences. So let's say a sequence A1, A2, A3 is defined by letting A1, the first term, be 3, and then you have a recursive formula. So AK is 7 times AK minus 1 for each integer, k that's at least 2. So we're going to do two things here. First, we want to find a formula for a sub n that only depends on n. So A1, our first term is 3. Now let's use our recursive formula to find A2. It's 7 times the previous term, A1, 7 times 3, or 21. A3 would be 7 times its previous term, A2, 7 times 21, which equals 147. Okay, and so on. So now if we want to write a formula for an in general, we need to find a pattern here. So if I look, A1 was 3, A2 is 21, which was 3 times 7, A3 was 147, it's 3 times 7 squared. So do you notice the pattern here? From this, you can probably see the pattern in general. An is 3 times 7 to the n minus 1. So there's our formula that only depends on n. It's no longer a recursive formula. So now for part B is I want you to prove this formula. So part B, prove that an is 3 times 7 to the n minus 1 for all n greater than or equal to 1. So this formula, you're saying it's true for all integers greater than or equal to 1, which means you need to use induction here. Now, because if we look back at our recursive relation, it only depended on the previous term, you can just use regular induction and not strong induction here. Okay, so let's do our basis step for the induction. The initial value is n equals 1. So A1, we know A1 is 3, and that's the same thing you get from plugging in n equals 1 into the formula 3 times 7 to the n minus 1. So this means our formula is true for n equals 1. So now let's look at the inductive step. Let k be any integer where k is at least 1. And we're going to assume that the formula is true for k. And now we need to show that it's true for the next value, k plus 1. Well, if k is at least 1, that means k plus 1 is at least 2. And that means that we can use our recursive relation for ak plus 1. It'll be 7 times ak plus 1 minus 1. So that's going to be 7a sub k. Well, we have a formula for this, right? It's up here. So I can plug that in. I'll get 7 times 3 times 7 to the k minus 1. And these 7s here, I can combine them. The 7 has a power of 1. So when you combine them, you add the powers, and it would be 7 to the k. And that's exactly what we needed to get to. If you plug in for our formula, if you replace n by k plus 1, this is the formula you need to get. So we've finished the inductive step, which means we're done with the induction and we've proven the formula is true.